Hi students, in this video let's see how to solve RSA problem. So the problem given here is apply RSA algorithm to perform encryption and decryption with the following parameters: P equal to 7, Q equal to 11, E equal to 17, M equal to 8. The steps to be followed for performing RSA algorithm is: first one, select two prime numbers P and Q, and we have to calculate the value n, which is equivalent to P into Q, and we have to choose an integer E which is less than n, and we need to calculate pi of n is equal to P minus 1 multiplied by Q minus 1. And the next step is to perform encryption. The formula is C equal to m power E mod n. Here m is the message and E is the selected integer, n is the multiplication of P and Q. So C is the ciphertext. Then we have to calculate D so that we can perform decryption. D is an integer such that D into E is congruent to 1 mod pi of n. And finally we need to perform decryption to get the plain text m equal to ciphertext power D mod n. So the given values are P equal to 7, Q equal to 11, E equal to 17 and M equal to 8. P and Q indicate prime numbers, E is the known key value and M is the message which is to be transferred. The first step is to find the value n is equal to P into Q, that is the multiplication of two prime numbers. 7 into 11 equal to 77, and the selected integer is 17, and we just perform encryption by using the formula C equal to m power E mod n. Apply the values 8 power 17 mod 77. We couldn't find the value 8 power 17 mod 77, so that we need to split into 8 power 8 the whole power 2 into 8. So 8 2s are 16. 16 plus 8 power 1 is equal to 8 power 17 mod 77. By solving this power modulo operation, we are getting the value of ciphertext as 57. This value is going to be transferred to the receiver, which is derived from by using the receiver's public key value E. So after getting the value C, the receiver will apply his or her private key D to find the actual message M. So to get the private key value of receiver, he has to calculate the value D. So D E is congruent to 1 mod pi of n. For this calculation we need pi of n value. Pi of n is equal to, the formula is given here, P minus 1 into Q minus 1. So pi of n is Euler's torsion function. N can be written as P into Q. So it can be expanded as pi of P into pi of Q. So if P is the prime number, then pi of P is equal to P minus 1. So that we can write it as P minus 1 into Q minus 1. So apply the formula here. P minus 1, 6, 7 minus 1, 6, 11 minus 1, 10. 6 into 10 is 60. So pi of n value is 60. Apply this value here. So D into 17 is congruent to 1 mod 60. Then the value of D can be written as E inverse mod pi of n. So 17 inverse mod 60. So to calculate the value 17 inverse mod 60, we need to apply extended Euclidean algorithm. According to this algorithm, we have to write the maximum number as first and the minimum number as second. And we just write 1, 0, 0, 1 and Q here. So 60 divided by 17, the quotient is 3 and the remainder is 9. And we have to fill these two places like 1 minus 3 into 0, which is 1. 0 minus 3 into 1 minus 3. So we need to check this value. Until this value is 1, we have to repeat the step. So performing the same step, 17 divided by 9, the quotient is 1, the remainder is 9. 0 minus 1 into 1 minus 1. 1 minus 1 into minus 3, which is plus 4. Then 9 divided by 8 is 1. The remainder is 1. 1 minus 1 into minus 1, which is 2, minus 3 minus 1 into 4, that is minus 7. So now we are getting the value 1 here. So just stop this procedure. And we are having two values, 2 and minus 7. How do you choose between these two values? If the question is 60 inverse mod 17, the value is 2. And if it is 17 inverse mod 60, the value is minus 7, the second value. So now the question is 17 inverse mod 60. So the second one is the answer. Minus 7 mod 60 is equal to 53. So that is the value for D. And we just perform decryption. The formula is M equal to C power D mod n. C is the transferred value which is sent by the sender. That is 57 power 53 mod n. N value is 77. By applying power modulo, we are getting the message as M. So it can be proved.